let's rewind to 2020. The AI world got hit by this one research paper that just changed everything. It wasn't just a small step forward, it was a giant leap in how we thought AI could even learn. The paper was titled Language Models Are Few-Shot Learners. And today, we're going to dive into what made its subject, GPT-3, so special. How it basically tore up the old rulebook and wrote a completely new one.
Okay, so you got to understand what things were like back then. Before this paper, if you wanted to teach an AI a new trick, say translating French to English or winning at a trivia game, it was a massive pain. It involved a very specific and frankly pretty grueling process. That old-school process was called fine-tuning, and it meant you had to literally spoon-feed the AI this enormous, custom-built data set. I'm talking thousands, sometimes hundreds of thousands, of examples just for one specific job. It was slow, it was super expensive, and the worst part? You had to do it all over again for every single new thing you wanted it to learn.
But what if a model could just skip all that? What if it could pick up a new skill right there on the spot just by seeing a few examples right in the moment? And that, right there, is the game-changing idea at the heart of the paper we're breaking down today.
So, to really get how big of a deal this was, we've got to talk about the old way of doing things first. You need that context to see why GPT-3's approach wasn't just a step up, it was a whole new staircase.
Right, so the standard method was this thing called fine-tuning. The idea was you'd take a big general AI that already knew a lot from being trained on the internet. Then you'd basically retrain it, tweaking its internal brain using another huge specialized dataset to teach it one specific new skill. The thing is, fine-tuning was kind of clunky. It had some serious downsides. First, like we said, you needed a brand new, massive dataset for every single task. Second, the model often became this one-trick pony. It got great at its one job, but was useless at anything even a little bit different. And sometimes it would find these weird shortcuts in the data to get the right answer. Basically, it would learn to cheat instead of actually learning the skill. And this is where GPT-3 strolls onto the scene. The researchers behind it didn't want to just make fine-tuning a little bit better. Nope. They came in with this totally wild idea. It all boiled down to one thing. Just go huge. And when I say huge, I mean 175 billion. Yeah, that number is everything. That's how many parameters, you can think of them as internal dials, the model had. To give you some perspective, that was 10 times larger than any similar AI model out there. The big bet was that at this absolutely insane scale, maybe, just maybe, new skills would just pop into existence. And you know what? It worked. Instead of that painful fine-tuning process, GPT-3 used what the paper calls few-shot learning. There's no retraining. You just show the model what you want by giving it a couple of examples in the prompt. It's the difference between giving someone a textbook and making them study for weeks versus just showing them how it's done a couple of times. So the team tested this out in 3 main ways, which you can see right here. First up, you've got 0 shot. You just tell it what to do, no examples. Then 1 shot. You give it one single example to copy. And finally, the big one, few shot, where you give it a handful of examples so it can see the pattern you're going for. And this is where it gets really interesting, and it's all captured in this quote from the paper. What they found was that the bigger the model, the better it got at this new kind of learning. Basically, these giant models weren't just learning facts anymore. They were becoming meta-learners. They were learning how to learn on the fly, just from the context you gave them. So, did it actually work? Was this radical new idea a success? Well, let's get into the results, because honestly, the numbers here are pretty wild. Okay, check out this graph from the paper. It basically tells you everything you need to know. Along the bottom, you have the model size getting bigger as you go right. Up the side, you have how well it performs. And the trend is crystal clear. Bigger models do better. But look at that orange line, the one for few-shot learning. It's shooting upwards way faster than the others. That proved it. The biggest models got the biggest benefit from just a few examples. All right, let's put some real numbers on this. Take a look at this trivia benchmark. The old champ, a model that was heavily fine-tuned just for this task, scored about 60%. GPT-3, with 0 fine-tuning, just a simple instruction, walked in and beat it, scoring over 64%. Then, when they gave it just a few examples, its score jumped to over 71%. I mean, it just blew the old record out of the water, and it barely had to try. And it wasn't a fluke. We see the exact same story on another really hard test called Lombarda, where the model has to predict the final word of a paragraph.
The old state-of-the-art was 68%. GPT-3, with a few examples, scored an incredible 86.4%. That is not a small improvement. That's a whole new league. Now, it wasn't all sunshine and rainbows. The model wasn't perfect, and the researchers were totally honest about that. For instance, it really struggled on tasks where it had to compare two different pieces of text, and some logic puzzles were still a bit beyond it. So, yeah, it was a massive leap, for sure, but it definitely wasn't the final answer. Okay, so when you create something this powerful, something that can generate text this good, you're forced to ask some really tough questions. With this kind of breakthrough power comes a whole lot of responsibility. And this brings up a really personal question for all of us. I mean, be honest. If an AI wrote something, would you be able to tell? Could you spot the fake?
Well, the researchers actually tested this. They showed people news articles. Some were real, some were written by the AI. And the results you see on this graph are honestly a little scary. As the models get bigger, moving from left to right, people's ability to spot the fakes just tanks. For the biggest model, the 175 billion parameter one, human accuracy dropped to just 52%. 52! That is basically a coin toss. People were essentially just guessing. At that size, the AI's writing was indistinguishable from a human's. And the paper's authors, they didn't pull any punches on this one. They called it a concerning milestone. The potential for mass-producing believable fake news wasn't some sci-fi concept anymore. It was real, and it was here.
And that wasn't the only problem. See, when you train a model on a huge chunk of the internet, it doesn't just learn the good stuff. It learns our biases too. For example, it started associating jobs like banker and sheriff with men, and jobs like receptionist and nurse with women.
And this wasn't just about gender. The same patterns showed up with race. This chart shows how the model learned to attach different feelings, positive or negative, to different racial identities. And this is so important to get. The AI wasn't programmed to be biased. It was just acting like a giant mirror, reflecting all the biases that were already out there on the internet for it to learn from. So, what's the big takeaway from all of this? The GPT-3 paper proved that just making a model bigger, ridiculously bigger, doesn't just make it better. It unlocks completely new abilities, things we never programmed into it. That's the mind-blowing part. But it leaves us with this huge critical question. As we keep making these things even bigger, by another 10 or 100 times, what other crazy abilities are just waiting to emerge? And more importantly, what new responsibilities does that put on all of us?